In this tutorial, we're going to talk about arrays in Java. We use arrays to store a list of items, like a list of numbers, or a list of people, or a list of messages. Let me show you. So here we have an integer variable. We want to convert this to an integer array. So right after int, we add square brackets. Now we have a compilation error because we're storing a single number in this array. So to fix this, we need to remove 1. Because arrays are reference types, we need to use the new operator here. Then we repeat the type one more time, int array. And here in square brackets, we specify the size or the length of this array. How many items do we want to include in this array? Let's say 5. Also, we should change the name of this variable from number to numbers because we're dealing with a list of items. So always pay attention to the name of your variables. Now, we can access individual items in this array using an index. So we type numbers, square brackets. To reference the first element or first item, we use 0. Now we can set this to a value like 1. Similarly, we can set the second item to 2. Now, what if we use an invalid index? Let's say 10. This array doesn't have 10 items. So let's see what happens. Numbers of 10, we set this to 3. When we run this program, we get an exception. Exceptions are Java's way to report errors. So in this case, an exception was raised and our program crashed. We'll talk about exceptions in detail later in the course. So now let's remove the last line and print this array. So SOUT tab numbers. Let's see what we get. We get this weird string instead of the items in our array. Here's the reason. By default, when we print an array, Java returns the string, which is calculated based on the address of this object in memory. So if you have another array and we print that, we're going to see something different because each object is going to be in a different memory space. Okay. Now, how can we see the actual items in this array? Well, we have a class in Java called arrays. Let me show you. Arrays. So this class is defined in java.util package. Let's press enter. Now, this is imported on the top. Beautiful. So we can use the dot operator to access the members of this class. Here we have a method called toString. Now, as you see, this method is implemented multiple times. So in the first implementation, this method gets a float array. In the second implementation, it takes an integer array, and so on. So for all primitive types as well as reference types, this method is implemented multiple times. This is what we call method overloading. Now, we can call this method and pass our integer array, and this will return the string representation of this array. So we can cut this from here and pass it to our print method, like this. Now, let's run the program one more time, and here's our array. Beautiful. So the first 2 items are initialized, the others are set to 0 by default, because here we're dealing with an integer array. If we had a Boolean array, all items by default get initialized to false. If you have a string array, all items get initialized to an empty string. Okay? Now,
that's not entirely true. If you have a string array, everything gets initialized to null, which is actually quite different from empty string. So everything gets initialized to null. That's the same way with any reference type. If you allocate an array of reference types, it will be initialized with null. Null because basically that's 0, right, as I said. Okay. One thing I might mention here, implicitly when you call print line, in a lot of cases in Java, it will automatically go call toString for you. Namely, that's the toString on the object. So without writing that, what you were seeing initially is it was basically calling numbers.toString and passing that in. That was actually what was happening in the first version, was equivalent to this. So that toString method is on the array. That's what produces that ugly code. But you'll notice what he's doing there is slightly different. So it's arrays dot toString and passing in numbers. Okay? Because they look very, very similar, but they don't have the same effect. So everybody see that? They look very, very similar. They both have two-string in there, but they're not calling the same two-string method. So in this first instance, I'm calling the two-string on the array. In this instance, I'm calling the two-string on the array's class, the class named arrays, which isn't actually an array. Arrays is a class, it's not actually an array. Cool? This gets weird really quickly with Java. This is one of those things that takes a little bit to understand and get. Questions? And the arrays class, by the way, is your best friend. There's a lot of useful stuff over there for working with arrays.
This syntax for creating and initializing an array is a little bit tedious, and it's an older syntax. There is a newer way to initialize an array if we know the items ahead of time, like in this case. So I'm going to remove these two lines. I'm also going to remove the new operator. Here we use curly braces, and inside these braces, we add all the items in this array. Let's say 2, 3, 5, 1, and 4. Now we have 5 items, so the length of this array is going to be 5. We can read that using the length field. So if we type numbers dot, look here we have this field. Look at the icon, it's an F. So this is a field which is like a variable in a class, and the type of this field is an integer. So this returns the number of items in this array. Let's get that and print it using our print method, like this. Take a look. So we get 5. Now in Java, arrays have a fixed size. So once we create them, we cannot add or remove additional items to them. They have a fixed length. If you want to be able to add or remove additional items from an array, you should use one of the collection classes that we'll talk about later in the course. For now, all I want you to remember is that arrays have a fixed length. Now currently our array is not sorted. These numbers are in some kind of random order. We can easily sort this array using the sort method of the arrays class. Let me show you. So I'm going to remove this line and call arrays.sort. Once again, you can see this method is overloaded because it's implemented with different parameter types. So we call this method and pass our numbers array. Now, when we run this program, we can see our array is sorted. Beautiful. So you have learned that we use arrays to store a list of objects. In Java, we can also create multi-dimensional arrays. For example, we can create a 2-dimensional array to store a matrix, or we can create a 3-dimensional array to store data for a cube. These are useful in scientific computations. Let me show you. So here we have a single-dimensional array. To convert this to a 2-dimensional array, we need to add another pair of square brackets. Now we have a compilation error because we need to repeat these brackets on the other side. So let's say we want to create a 2x3 matrix. So 2 rows and 3 columns. We add another brackets here and change these lengths to 2 and 3. So now we have 2 rows and 3 columns. Now to access individual items in this array, we need to supply 2 indexes. First, the index of the row. So we can go to the first row and then the first column and initialize that to 1. Now let's print this. So SOUT tab. Once again, we use our arrays class dot toString and pass this object. Take a look. Once again, we get this weird string because here we're dealing with a multi-dimensional array. To solve this problem, we need to use another method in this class called deep toString. We use this for printing multi-dimensional arrays. Take a look. Now we have this matrix which has 2 rows, and in each row we have 3 columns. We can also create a 3-dimensional array. All we have to do is to add another pair of brackets and specify the length of that dimension. Pretty easy. Now what about the curly brace syntax? Let me show you. So let's revert this back to a 2-dimensional array. We're going to get rid of the new operator and use curly braces. Now let's say in this matrix we're going to have 2 rows and 3 columns. So each row is an array itself. because it's a list of items, right? So we add another array here. Let's say 1, 2, 3. Then comma. Now we add the second row, which is another array. In this row, we're going to have 3 numbers, 4, 5, and 6. Now let's remove this line. We don't need it anymore. And print this array. So here's the end result. Yeah, I've learned a lot about variables.
A lot of Java developers like to refer those as arrays of arrays, and because internally they're what we call jagged arrays, where each of those rows don't have to have the same length. So the way he had set it up, both of those rows had 3 elements, but that's not a requirement to Java. The outer thing is an array of arrays, and the inner thing is an array of integers. But each of those nested arrays are completely separate. So that gets pretty interesting pretty quickly when you start playing around with those things.
So here's the end result. Yeah, I've learned a lot about variables. Yeah, I've learned that when declaring them, we need to initialize them, and we can always change their value later on throughout the lifetime of our programs. However, there are times that we don't want the value of a variable to change. For example, let's declare a variable called pi and set it to 3.14. Now here we need to add an f to represent this as a float, because by default, Java compiler sees this number as a decimal. Okay. Now, you know that we use pi to calculate the area of a circle. What if before we calculate the area of a circle, I come here and type pi equals 1? Then all our calculations are going to get messed up. We don't want this to happen. That's when we use constants. So if we type final here, Java compiler will treat this as a constant. So once we initialize this, we cannot change its value later on. You can see here we have a compilation error, and it says cannot assign a value to final variable pi. So pi is a final variable or a constant. Now by convention, we use all capital letters to name constants. So this should be pi. Beautiful. Now I tell you a little side story. In one of my early courses that I created years ago, that was C# Basics for Beginners. There I used the same example to teach the concept of constants, but I pronounced this word as p instead of pi. And believe it or not, to this day, people make fun of me for saying p instead of pi. But that's how we learned this back in Iran. We pronounce it as p, and I think Greek people also say p. But anyway, I just thought to share this video to change the mood. Now we're done with constants. Next, we're going to talk about arithmetic expressions. In this tutorial, we're going to talk about arithmetic expressions in Java. So in Java, we have the same arithmetic operators that we have in math. We have addition, subtraction, multiplication, division, and modulus, which is the remainder of a division. Let's look at a few examples. So I'm going to declare an integer called result. And here we can type 10 plus 3. Now when we print result, it's going to be 13. Pretty straightforward. There you go. So this is addition. We also have subtraction, multiplication. Division is an interesting one. Let's take a look. So here the result is a whole number, because in Java, the division of 2 whole numbers is a whole number. If you want to get a floating point number here, you need to convert these numbers to a float or a double. Let me show you. So we prefix this number with parentheses, and in parentheses we type double. Now we are casting or converting this number to a double. Similarly, we should do that here. And now we have a compilation error because on the left side, we declared an integer, but here the result of this expression is a double. And by the way, an expression is a piece of code that produces a value. So what we have here is an expression because it produces a value. So to fix this problem, we need to change this to double. Now when we run this program, we get this floating point number. Beautiful. So these are the arithmetic operators. And these numbers that we have here are called operands. We also have increment and decrement operators. Let me show you. So I'm going to declare a new variable, int x, we set it to 1. Now, if you want to increase the value of x by 1, we use the increment operator. Now let's print this on a terminal. So we get 2. There you go. We can apply this operator as a postfix or as a prefix, and we get the same result. Take a look, 2. However, if we use this on the right side of an assignment operator, we get different results. Let me show you. So I'm going to declare another variable, y. We set it to x plus plus. In this case, because we have applied the increment operator as a postfix, first the value of x will get copied to y, so y will be 1, and then x will be incremented by 1. So if we print x and y, x is going to be 2, and y is going to be 1. Take a look. So x.
The way I usually explain that is when you're doing postfix, it happens after the line executes, is the way I usually say it. So you say run the code that's in that line, and then run the increment afterward. Versus prefixes, it runs before the line instead of after the line. So that's usually how I think of it.
X is 2 and y is 1. Beautiful. However, if we apply this as a prefix, first, x will be incremented by 1, so it will be 2, and then it will be copied to y. So in this case, both x and y will be 2. Take a look. So we get 2 and 2. Now, what if you want to increment x by more than 1? Let's say by 2. Well, there are 2 ways to do this. Let's remove y. We don't really need it anymore. We can write x equals x plus 2. So first, we add 2 to x. The result will be 3, and then 3 will be copied into x. The other way is to use the augmented or compound assignment operator. So we can write x plus equals 2. What we have on line 8 is exactly identical to what we have on line 7. But as you can see, it's shorter. So this is a better way to write the same code. Now, this is one of the augmented assignment operators. We have the augmented assignment operator for other arithmetic operators. So we can type x minus equals 2, and this will reduce the value of x by 2. We also have multiply and divide. So these are the augmented or compound assignment operators. All right, now I've got a question for you. Here we have declared this variable x equals to 10 plus 3 times 2. What do you think is the result of this expression? The result is 16. Let's run this program and find out. So run, there you go. We got 16. But why? Well, this is a very basic math concept that unfortunately a lot of people don't know. In math, the multiplication and division operators have a higher priority, so they get applied first. In this example, this expression 3 times 2 is evaluated first. The result is 6, and then 6 is added to 10. That's why we get 16. Now, if you want to change the order of these operators, you can always use parentheses. For example, if you want this expression to be evaluated first, we wrap it in parentheses. So, like this. Now, Java compiler will first evaluate this expression. The result will be 13, and then 13 is multiplied by 2. So we get 26. Take a look. There you go. So be aware of the order of these operations. Parentheses always have the highest priority. Then we have multiplication and division. And finally, we have addition and subtraction.
A question there. Logical operators, ands and ors. Do those have the same order of precedence? Most languages agree on the order of precedence too. Just a heads up. So ands and ors are not the same precedence. Ands and ors don't land at the same level. Which one's higher?
Okay.
Why?
I just remember you kind of groups your hands together.
Yeah. So the good way to think about it is an and is kind of like a multiplication, and or is kind of like a plus. In fact, it kind of works that way. So, for instance, if I think about things in terms of binary, remember when I'm thinking about multiplication and division, if I do this with ones and zeros, I got kind of the same behavior. So like if I take 0 times 0, right, I get 0. If I take 1 times 0 times 1, right, I get 0. 1 times 0, I get 0, and then the only time I get 1 is if I take 1 times 1, right? Which actually, that's exactly what our and expression is. It's only true if 1 and 1 are true, right? So actually, ands and ors, ands and multiplication have a lot in common. To the point that something called Boolean algebra actually uses the time symbol as the and sign. The other side of things with ors, if I do the same game with pluses, 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And this is where things get weird. You have to change the math a little bit. If you're thinking about it in ands and ors, right? Because normally if you add 1 and 1, well then that gives you 2. But if you're doing 1 and 1, you get, or 1 or 1, you get 1. So oftentimes we'll represent oftentimes you can, the Boolean algebra way of doing things is this sort of manner, is they're using the pluses and times as a way to represent the ands and ors. Because you really can, right? As long as you treat those variables as either being 1 or 0, nothing in between, nothing greater, nothing smaller, you can do that kind of thing. So it follows the same rules as addition and subtraction in a lot of ways. So you can say your ors, right? Your or over here has a lower precedence than and for the same principle that you want to group things together with multiplication. Cool? Because it works better for the algebra purposes. So do keep that in mind. Your ands and ors are not read from left to right. They're read the ands first and then the ors second. So oftentimes, anytime you're mixing ands and ors, the biggest thing I would recommend is to always use parentheses. If you have a mix of ands and ors, use parentheses. If they're all ands, you don't need to. It'll always be left to right. If they're all ors, you don't need to. It'll always be left to right. So but we do want to introduce parentheses if there's a mix of ands and ors. Cool. That's a common factor. And that's actually true for basically every language out there in the sun. This is not a Java specific thing. So JavaScript and C# have the same behavior.
In this tutorial, we're going to talk about casting and type conversion. So I'm going to declare a short variable called x and set it to 1. And then I'm going to declare an integer called y and set it to x plus 2. In this example, we're adding a short to an integer. What do you think the result is going to be? Well, let's take a look. So SOUT, let's print y, we get 3. That is what you were expecting. But let me explain what happens under the hood for this expression to get executed. Because we're dealing with two different types of values, one is a short, the other is an integer, one of these values should be converted to the other type so they are equal. Now I got a question for you. How many bytes do we have in a short variable? We have 2 bytes. How many bytes do we have in an integer? 4 bytes. So any values that we store in a short variable can also be stored in an integer variable, right? So when this piece of code is going to get executed, this is what's going to happen. First, Java looks at the value in this variable. It's 1, right? It's going to allocate another variable, an anonymous variable somewhere in memory. We don't know where that is. We don't know the name of that variable. It doesn't have a name. It's anonymous. That variable is going to be an integer. Then Java is going to copy the value of x into that memory space. and then it will add these two numbers together. This is what we call implicit casting. Let me type it here. Implicit casting. That means automatic casting or automatic conversion. We don't have to worry about it. Whenever we have a value and that value can be converted to a data type that is bigger, casting or conversion happens implicitly or automatically. So byte can be automatically converted to short, and this can be converted to int and long. Okay. Now, what about floating point numbers? Let's look at an example. I'm going to change this to a double 1.1. Now here we have a compilation error because on the right side of the assignment operator, we have a floating point number, a double. On the left side, we have an integer. So we need to change this to double. Now, when we execute this code, we're going to get 3.1. Let's verify this. There you go. Now let's see how casting happens here. In this case, we're dealing with a double and an integer. An integer is less precise than a double because in a double, we can have digits after the decimal point. So in this example, Java is going to automatically cast this integer to a double. So that will be 2.0, and then 2.0 will be added to 1.1. Okay, so back to this chain. Here we're going to have float and then double. So as a general rule of thumb, implicit casting happens whenever we're not going to lose data. There is no chance for data loss. Now, what if we want y to be an integer? So in this example, we don't care about the digits after the decimal point. We want to see 3 on the terminal. How should we do this? This is where we should explicitly cast the result. So we should cast x to an integer like this. Parentheses, int. This is explicit casting. We convert x to an integer, so the result will be 1 without a decimal point. 1 will be added to 2, and y will be 3. Take a look. There you go. So this is all about implicit and explicit casting. Now, this explicit casting can only happen between compatible types. So all these types are compatible because they're all numbers. But we cannot cast a string to a number. In other words, if x was a string, like this, let's say 1, we cannot cast x to an integer because they are not compatible. So how do we do this? Well, for all these primitive types you have learned, we have wrapper classes. So in Java, we have a class, which is a reference type called integer. This class is defined in java.lang package. And in this class, we have a method called parseInt. So this method takes a string and returns an integer. So integer is the wrapper class for the int primitive type. We also have short, and in this class we have parseShort. So it takes a string and returns a short. Similarly, we have float and double, and obviously the name of these methods are different. So here we have parseFloat. So back to this example. Let's say we get x as a string and we want to convert it to an integer. This is how we do it. Integer dot parseInt. We pass x here and then add it to 2. Take a look. So we get 3. Now you might be curious why this matters. Why should we parse or convert a string to a number to add it to something else? Well, pretty much in most frameworks for building user interfaces, whether you're building a desktop or a mobile application or a web application, we always receive input from the user as a string. So if you have a form with a bunch of text boxes or drop-down list, almost always we get values as a strings. So that's why we need to convert these strings to their numeric representation. Okay? Now, what if x is a floating point number here? What will happen when we try to parse this as an integer? Let's take a look. Once again, we get an exception, which is how Java reports errors to our programs. We're going to talk about exceptions in detail in the future. So if the user enters 1.1, we cannot use this method. Instead, we should use float or double. Let's say double because that's easier. Double parse double. So we parse this number as a double, add 2 to it, and then store the result in a double. And then we will get 3.1. Beautiful. Next, we're going to look at the math class for performing mathematical operations. In this tutorial, we're going to look at the math class for performing mathematical operations. So in Java, we have this math class that is defined in java.lang package. So it's always there. We don't need to explicitly import it. Now, this class has a number of useful methods. The first method I'm going to show you is the round method. And with this, we can round a floating point number to a whole number. So as you can see, this method is overloaded, which means it's implemented twice. In the first implementation, it takes a float and returns an int. In the second implementation, it takes a double and returns a long. So let's pass 1.1 as a float to this method and store the result in an integer, like this. Now we print the result and we get 1. Beautiful. Another useful method is ceil or ceiling, which returns the smallest integer that is greater than or equal to this number. So the ceiling of 1.1 is 2. Now here we have a compilation error because this method returns a double, but we're storing the result in an integer. So here we need to explicitly cast this to an integer. And now you can see the ceiling of this number is 2. We have another useful method that is floor. So the floor of a number is the largest integer that is smaller or equal to this number. In this case, it's going to be 1. Let's take a look. There you go. Another useful method is max, which returns the greater of 2 values. And once again, this method is overloaded. So in the first implementation, we get 2 integers. We have other implementations for longs, floats, and doubles. So let's pass 2 integers here, 1 and 2. This will return the greater number, which is 2. There you go. Similar to this, we have min. That's pretty straightforward. Another useful method is random for generating a random value between 0 and 1. Once again, we get a compilation error because this method returns a double. So let's change that to double. Now, every time we run this program, we get a different number. And this number is a floating point number between 0 to 1. Now, what if we want a number between 0 to, let's say, 100 instead of 0 to 1? Well, we simply multiply this by 100. Take a look. So every time we run this, we get a different number between 0 to 100. Now, if we don't want these digits after the decimal point, we can either round this number or cast it to an integer. Let me show you. So we can call math.round and pass the result of this expression. So I'm going to cut this at parentheses to call the round method and then paste that expression. Now let's run this code.
It's worth mentioning if you're doing this with floating point numbers and random number generation, make sure you always use floor. Always floor, never round, never ceil, because of how that random number generator works. It guarantees that you're going to get a number starting from 0 up to, but not including 1. And so there's a little bit of bias kind of built in there and whatnot. If you try to do round like this, you're going to have some issues with the randomness. So you want to make sure that you're doing floor there and not round.
So every time we get a double, we still have the fraction here. So we can change the type to an int. Now we have a compilation error because the round method returns a long, but here we have declared an integer. This is one of those cases where implicit casting cannot happen because we have a value that is represented in 8 bytes of memory, and we want to store that in a variable that has only 4 bytes of memory. So implicit casting doesn't work, but we can use explicit casting because we know the result of this expression is a number between 0 to 100. So we can definitely store it in an integer. So let's add int here. Now let's run this again. There you go. Now, what if we don't use the round method here? Let's see what happens. So I'm going to remove the call to the round method and simply apply this casting over here. Let's see what we get. Now, every time we run this program, we get 0. Do you know why? Because here we're applying this casting to the result of this method call, not this entire expression. As you saw earlier, every time we call the random method, it generates a number between 0 to 1. So when we cast that number to an integer, we'll lose the fraction. We always get 0, and 0 times 100 is 0. To solve this problem, we need to wrap this entire expression in parentheses. So we add parentheses around this. And now, when we run this, we get an integer between 0 and 100. Quite often when we work with numbers, we need to format them as currency values. For example, we might have a number like this. Imagine this is the price of a product. To display this to the user, you want to add a dollar sign here and separate every 3 digits with a comma. Or we might have a number like 0.1, and we want to represent this as a percentage value. So instead of 0.1, we want to display 10%. So in this tutorial, I'm going to show you how to format numbers in Java. We have this class number format that is defined in java.text package. In this package, we have a lot of classes for handling text, dates, numbers, and so on. So let's press enter here. It's imported on the top. Beautiful. Now,
one part I want to preface this by, Java formats its way in a way that's going to seem really weird this semester. It's going to seem really weird in this semester. Because Java formatting is not like C#, it's not like JavaScript, it's probably not like anything you've encountered before, okay? The reason that it exists the way it does is because it borrowed its syntax from C++, okay? But basically no other language have done that in recent history, right? So most languages have figured out that this is a problem and have chosen a different approach, right? So the approach for formatting that you see again in C# and JavaScript is not the same. You do want to make sure that you spend some time learning this format because it does apply to Android and it will come up. I can guarantee you the formatting tools will come up for a few assignments throughout the semester. Cool. So just a heads up, it's going to look weird. It's definitely something that we need to talk about. And I'll kind of let him go through his discussion, and then we can talk about it and kind of expound on what the details are there.
I'm going to declare a variable, so let's give this variable a name, currency. Now we need to instantiate this, so new number format. However, we get a compilation error here. Let's take a look. Number format is abstract. It cannot be instantiated. So in Java, we have this concept of abstract classes. So some classes are abstract and they're basically like a half-baked cake. We cannot use the new operator to create an instance of them. We're going to talk about abstract classes and why they exist later in the course. For now, remember that we cannot create an instance of the number format class because it's abstract. So there is another way. Let me show you. This class has a bunch of methods that start with get. So we have get currency instance, and when we call this method, this will create an instance of the number format class and return it. So instead of using the new operator, we're going to use this method here. This is what we call a factory method because it's like a factory. It creates new objects. Now look at the return type of this method. It's a number format object, okay? So we call this method. Now we get the return value and store it in a variable of type number format called currency, okay? Let me temporarily zoom out so you can see all the code. There you go. So on the right side of the assignment operator, we're calling the get currency instance method. We get the result, which is a number format object, and store it in this variable, okay? Now I'm going to zoom in so you can see clearly. All right, that's better. Now this object has a method for formatting values. Once again, you can see this method is overloaded. We have multiple implementations. We can give it a long or a double or whatever. So I'm going to call this method and pass a value like 1234567.891. So we have 3 digits after decimal and a few other digits here. Now this method will return a string representation of this number formatted as a currency. So let's get that and store it in a string variable like result. And then we're going to print result on the terminal. See what we get. So we get this dollar sign. Every 3 digits are separated using a comma, and we only have 2 digits after decimal point. So this class is very handy in formatting numbers as currencies. We have another method for formatting a number as a percent, and that is get percent instance, right? Now it returns an instance of the number format class specialized for formatting numbers as a percent. So we need to rename this variable from currency to percent. Now we don't want to manually change this because there are multiple references to this variable. This other reference was not updated. So let me show you the proper way to rename objects in IntelliJ. If you right click here, you can see this refactor menu. And here we have rename. Now look at the shortcut on the right side. Unfortunately, it's not visible in my recording window, but on Mac it's Shift and F6. I always use shortcuts because they're faster. So let's press Shift and F6. Now we get this red box, and below this we can see a few suggestions for a better name. We can choose one of these or pick our own name. I'm going to change this to percent. And note that as I'm typing this, the other reference gets updated automatically. So this is very helpful. Now let's press enter. Okay, we're done with renaming. Now let's pass a different value here. So let's say we have a number like 0.1. We want to format this as a percent. Let's run the program. There you go, we get 10%. Beautiful. Now let me show you a cool technique. In this program, we don't really need this percent object because we have used it in a single place. It would make sense to have this as a separate variable if we have multiple references to it. So what can we do here? We can completely get rid of this object. So let's delete this piece of code. We're basically calling this method of the number format class. As you know, this method returns a number format object. So right after calling this method and before the semicolon, we can use the dot operator to access the methods or members of the number format object. So here we call the format method straight away and pass our value. This is what we call method chaining. We're chaining multiple methods together. So here's one method and here's another method. Now this returns a string, so we can store it in this result variable. Let me cut this expression from here and put it over here. Now we have double semicolons, so I'm going to delete one of them. All right, beautiful.
So while you can do that chaining, it is a valid thing to do in Java. I would recommend against doing the chaining. It typically ends up resulting in performance problems on the Android side. Part of that is usually if you're using a number format, you usually find yourself using it more than just once. That's okay as long as you're only using like the formatter once and throw it away. But that gets really costly. Use it once, throw it away. Use it once, throw it away. It gets really costly on Android because oftentimes that means you may be doing it once per frame, or in the worst case, you may be doing it for every number that's on the user screen. So if you think about it in the extreme case, let's say I've got a list of products or things that I'm rolling up and scrolling up and down the user screen, right? And you might not notice those little performance things down there you might not notice it when you're looking at that code. But let's say each of those things you're spinning through, those cards, have 5 different places you're outputting a number, right? And well, there's 20 cards on the user screen. You're looking at, okay, at any given time, there are 100 numbers on the user screen. You're creating a number instance for every one of those. And then if the user goes and flings and scrolls it really fast, every time it renders a frame, it's got to construct 100 numbers, 100 numbers, 100 number formats, 100 number formats. That might seem really minor. You'll see a noticeable jerk in the animation. Does that make sense for everybody? So there's a balance to how often you create number formats. There's a definite balance to strike. I would not recommend doing the chaining and creating them and destroying them in one step. That will get you into problems. I would recommend you reuse them where you can, but also be very careful about pushing them up to a certain point where they never die, if that makes sense. So if you push them out far enough, then you can put them in a static variable, and they basically never go away, never get replaced. then you will have problems with threading and memory leaks, etc., etc., etc. So usually the balance goes to your number of formats. You're going to push them up a little bit. They might. Usually, I avoid turning them into class variables. Sometimes you have to, but usually you don't. So usually I just define them in the method, use them all the times I need, and then throw them away at the end of that invocation. But sometimes you may find yourself needing to actually move it up a little bit further and make those class variables. Just a heads up. Cool. Or even function parameters that you're passing down. Method parameters you're passing down. Okay. Questions on that? Okay, so let's talk about formatting things in Java. He kind of took the easy approach, which we will be taking that approach where we can. It doesn't work all the time. Okay, so let me pull up Notepad++ again, which is we were here, language Java. In terms of talking about formatting, okay, in C#, you may have seen something to this extent. String name is equal to, I think we had to put a $sign in the front, and then we did like, here is first name, space, last name. Let me call that full name. So C# has this kind of approach to formatting, which just says, hey, put the $sign in front of it, and then you can put replacement strings in the middle. Right? So I can put the variable first name here and the variable last name there. All good so far? Similar things we can do. Let's say I want to spit out a price. Let's say I want a price string. That might be, again, $sign at the beginning, and I might do the price. Okay, so that would put the price in literally, but I need to do a little bit of formatting it with it. So one thing I can do is I can end this with a colon and say F2. F2 says format as a floating point number with 2 decimal places. So it's going to round it to the closest decimal point. I also typically want to add a $sign in there, so it might look like something like this. So stick a $sign in the front, and then keep 2 decimal places. That's one way you can represent it. An equivalent way to do the same thing, it's just a slight tweak, is I can say 0.00. Both of those will format the string in the same way. F2 is just a shorthand for the second approach. Means you don't have to list out a bunch of zeros. Okay. So, everybody good with that, right? These are hopefully the ones you've done before. As I said, Java's not the same way. Okay. So we can get to the same result using a very different syntax. Okay. So in Java, and I need to clarify this with uppercase string because it is a reference type. If I wanted to do the same thing with the full name, okay, Java doesn't have special quotes for anything. The only quotes you can use to delineate a string are the double quotes. That's it. There's no special like backticks. There's no special. Sometimes you can use a single quote. Single quotes are always a character. Okay. So, and we don't have this $sign. We don't have the @ sign. We have to do something a little bit different. So what we do instead is we say string.format. Use the string format method. And the string format method takes actually a variable number of arguments. You can pass it as many arguments as you want. but the first one has to tell it how to use the rest of the arguments. Okay. Pass as many arguments you want, but the first one has to tell it how to use all of the rest arguments. That first argument must be a string. Specifically, it must be a format string. Okay, first argument must be a format string. So if I'm trying to combine the full name, that would look something like this. %s space %s. And this is where the format gets viewed. Okay, this is where the format gets viewed. So %s, percent says here I'm going to put something in. This is a placeholder. Okay, so it's kind of like the curly braces. Curly braces say here I'm going to put some code. I'm going to put something into the string. I'm going to interpolate it. Here I'm saying, hey, this %s is a placeholder for putting something there. Okay, so percent says it's a placeholder, s says it's a string. So it says put a string here, okay, because the data type matters. And this right here is hoisted directly out of C. C and C#, this is directly hoisted out of C, specifically the printf statement in C. That's where that syntax comes from. Okay, so it's quite a bit of an older syntax has been around for a long time. I do believe that Perl and PHP have the same syntax, as well as I think Python has something similar. Okay, so it does happen occasionally. You might still occasionally run into this in Python, but this is where this is a little bit unusual. Okay, so I'm saying I want to put in 2 strings. If I run this code as is, it will crash. There will be an exception. Because when it tries to go do this, it'll say, hey, okay, where's my string? Where's the string that you want to put here? And it'll cough immediately at that first %s and say, oh, I can't go any further. Everybody with me? Okay, so I have to provide that string. The way I provide that string is as another argument to string format. So first name, last name, that's what we're looking at. So in order to do this conversion, I need to, if I want to put 2 strings together using that kind of thing, this is the pattern. Okay? Now, so %s, that's the easy one. Okay, so there's a few types in there. There's actually a lot of types in JavaScript in Java in terms of formatting. So in terms of type specifiers, as I just said, %s refers to a string. %d, this is the one that gets every student confused, doesn't represent what you think it does. %d is going to throw you for a loop. It's an integer. %d is an integer. Originally, I think the heritage of that term is it's d for decimal, not d for double. So d for decimal, that's an easy thing to miss in this mix. Okay. And actually, that's all kinds of integers. So bytes, shorts, integers, and longs, all of those are written out as %d. However, if you try to put out a floating point number using %d, it will complain, it'll crash, it'll throw an exception, it'll say, I can't do that, because this only supports integers. It doesn't support floating point numbers. So the types have to match what you're passing in. So everybody good with that? This is one of those few cases where when you're formatting and dealing with the formatting, you're going to be dealing with runtime exceptions rather than compile time exceptions, because Java can't detect these at compile time. versus it can detect most other things at compile time. Okay. Next up is %f, which stands for floating point. And that includes, that's both double and float. It works for both doubles and floats. It's easy to accidentally put a %d when you're thinking, oh, this is a double, right? Double is f, not d, because d is integer and f is float. Cool. So it's not just the letter that you would expect, it's that general sort of class of type that it is. Other types that you'll find in there, another one that's important is this is date or time related. If you say %t, if you're trying to just write out times or dates, you'll be spitting that out with the %t. Okay? Sort of mentioning that the %t is never by itself. You always have to say what part of the date are you going to output. But those are your basic starting points. So everybody good with that? Okay. So now here's where things get interesting. So let me say I want to reproduce the same logic that I had above. String price string is equal to string dot format, and I'm going to specify my format string as %f, because whether it's a double or floating point, I'm expecting my price, double or float, I'm expecting my price to be having decimal places. Okay, so I'm going to use %f. Okay. Now I want to get it to look the same way I had before, which is decimal points. I want to have 2 decimals after the point, and I want to have a $sign out front. Okay. So the decimal points, the way that I do some additional formatting is this is actually not the end of the story. %f or %s, any of those is not the end of the story. There's a lot more additional characters that you're allowed to specify how it's formatted. Okay? In large in part, those go between the % and the f. So the % is kind of the beginning of it, and the f is kind of the end of it. Right? So we're going to put in between there 0.2. 0.2. So 0.2f says show a floating point number rounded to 2 decimal places. Okay, now it's important that point is important. So it's 0.2. So it's 2 places after the decimal point. If I, on the other hand, didn't have the point, okay, if I said 2f, this would say put 2 spaces, put 2 places before the decimal point. Okay, this would say put 2 places before the decimal point. And depending on how you word this, these will either be filled with spaces or they'll be filled with zeros. So in this case, if I print out 1.5, this would just be printed out as 1. Okay. Actually, it would be printed out as space 1 because this pads it with spaces. Everybody good with that? So if you just add a number there, that's going to pad it with spaces if there's not enough space. On the other hand, if I say 0.2, which is kind of hard to tell because that's the font that they're using, but 0.2 is padded with zeros. So this will be 0.1, right? It will be padded with zeros instead of being padded with spaces. There's a lot of nuance to the little characters that you put into that format specifier. That's one thing I want you to pay attention to. Cool? Okay. Other things to pay attention to. So we want to go back to point 2. and I can't actually technically combine those things. So if I wanted to have space at the beginning, I could do like 5.2, and that would say, okay, I total want this number to be spit out as 5 characters, but 2 of those characters lying after the decimal place, which really means I'm only making space for 2 characters. So back to point 2. So that's mostly equivalent to what's here. Notice that there's one difference that I haven't dealt with yet. What's that one difference? What's the distinction between the C# and the JavaScript version, the Java version stuff? $sign, right? So the $sign is actually the easiest part. I just put it at the beginning. As long as it's not inside of a template string, you're okay. Okay. As long as it's not inside of a template string, you're okay. Except that the $sign is kind of oftentimes hijacked by Java to represent certain things. So, for instance, if I remember right, if I do $1 followed by the other things, I do believe that turns us, and maybe my memory is wrong, but I do believe that turns into, hey, I want the first argument, or $2 would be the second argument, etc. If I remember right. So I think actually I have to escape the $sign to do this properly in Java, if I'm not mistaken. So $sign instead of just a single $sign. Cool. Weird Java quirks. Those are some of the things you'll get used to once you get into formatting numbers, right? It's those kind of things that you have to just kind of learn and then remember how to do. If I needed to add text at the end, I could add text at the end by the same note merit. So if I wanted to say units, it would be back here. Similarly, up here, it would be, at the end. Just like I can add things outside. Cool. Okay. So that's the key to really unlocking formatting in the world of Java. Is if you want to get into the nitty-gritty, you have to deal with those things. One caution though, when we're writing mobile applications, these mobile applications are not just going to run on English devices. They're going to run internationally, and which means you have to deal with international issues. International issues crop up right here because not everybody represents numbers or currency or dates or times, etc. in the same format. Okay, so you do have to be very careful about how you do that representation. By default, string.format chooses the locale of the device that you're running on. So let's say your device is set to French, it will run it with the French rules. If it's set to German, it will run with the Germany rules. If it's set to China, it will run with the China rules. If it's set with Japanese or Indian, it will run with those locales in mind because they do things differently. Okay, so what are some of the things that they do differently internationally? Does anybody know what some of those things are?
Europe uses commas instead of periods for definition.
Yes. So Europe does use. They actually switch them. Europe switches commas and periods. So we're used to using periods for decimal points and commas to separate thousands. We assume the rest of the globe understands that. They don't. In fact, we're the oddballs out in a lot of ways. There's actually a lot more people internationally in other countries that use commas as the decimal points and dot as the thousand separator. So if you're running on a European device, if you're running on any of those devices, you actually have to switch. It has to behave the way that they expect. Okay, so those are things you have to watch out for. What else?
Regarding
I was gonna say, I think like either like the pound sign or like the euros. I think it's usually at the end, right? Instead of like at the beginning.
Yeah. So the currency symbol, right? The currency symbol may not be at the beginning or the end, and they may use a different currency symbol, right? So you've got European Union uses the EU. You've got Britain uses the pound. We've got yen over in Japan. So you have those different ways, and some countries put it at the beginning, and some countries put it at the end. You also have to figure out what symbol is it, right? Here I've hard coded in it as the dollar sign, so that presumes that we're talking in dollars. You also have to deal with currency conversions then. If you're changing the thing, because $5 is not the same as thing as 5 EU versus 5 yen. So you also have to figure out what the conversion ratio is potentially if you change. Which is where usually for currencies, you always want to represent them in your native currency. It's usually better to just go ahead and represent them in your native currency and not in other currencies, because those currency versions are fraught with peril.
So I just kind of wonder, like, what about like the cent symbol? Because like I
Yeah.
don't know if any other currency like is here we have like dollars and then cents. But like
Yeah.
I think everywhere else it just be like just fractions of whatever the currency is, right?
That's a good question. If you're you're talking about writing out in English.
You know what? Yeah, I just wondered, like, I guess visually, I think just represent as dollars, right? Like the cents is like,
Yeah.
I guess it's kind of
So, well, a lot of countries do follow the same way that we do. They just stick a currency symbol at the beginning or the end and use the dot to represent that it's portions of that. Other countries actually don't have a fractionating point, so their cents are just smaller units, right? So you say, hey, 100 is just 100, right? Your 1 is 1 cent. 100 is not a new unit, not a new kind. It's just you're using different bills, which means that those countries always have a lot of seemingly large bills because they always have extra zeros at the end. So that's the way that some countries approach it. They just always tack extra zeros onto the end of their bills. There's also a move at the moment for some countries maybe getting rid of, well, what if you get rid of pennies and things like that? Then things get really interesting. Yeah.
Would you like there's like Venezuelan peso or something the numbers for
The Venezuelan, explain me, because that's one that's new to me.
it's like I think it's like $1 for a million pesos or something.
Oh, okay.
in Venezuela.
Okay. Because the conversion ratio. Yeah. Yeah. It's like you just have to represent it in pesos, right? Kind of thing. Or represent in dollars and not both. Yeah. So at that point, you can't use any of those primitive types that we talked about, right? At that point, you have to use big integers or big decimals or big floats. There's specific types that work for very large numbers, namely big integer and such, and the family. And what they actually do is they'll represent the number as an array of bytes, which means they can actually be arbitrarily long as you have enough memory, right? But they do take up more memory. They are a bit slower to work with, but they can deal with bigger numbers. So big ints come up a lot with currencies. Another really common one is there's this idea of the crow and the lac. So we always separate our numbers as like thousands. But actually, a number of countries will separate things, what we might seem as weird. So that's pretty common internationally. You put a comma here and a comma there.
What have you just done?
Yeah.
That's heresy.
If I remember right, crow, black. It's very weird. It still breaks my brain. It still breaks my brain. The crow and the lack. It still breaks my brain. But they're not equidistant. They're not equidistant. There's reason in history for that, but it is so weird. And I feel like where I've heard that happens and used primarily is in India. But there are a number of countries around the world that use that. I think there are some Asian countries that do that as well. So be aware of that, right? Be aware that the commas may, or the thousand separators might not be at thousands. They might be otherwise arranged. Cool? Okay. So those are all things you have to watch out for. And that's one of the reasons why what he mentioned was to use the currency formatter. Because the currency formatter will take it from whatever number you get it to put it out into the user's current currency, their local currency. It won't do any sort of conversion, right? If you give it $5, it will represent it as 5 EU. If you give it $5, it will represent it as 5 pesos. Right, so you do have to manage the conversion from currency to currency yourself, but it will do the formatting for you. It's a gotcha. It will do the formatting for you, but it may not format it the way you want it to. In fact, I usually go ahead and tell it, always format it in US, because I don't want it formatted as 5 peso. I want it formatted as $5. So that's where things can get extra weird, right? So dealing with formatting on Android is extra hard because you have to deal with all the country differences. It's not something like in the world of the web and JavaScript. It's actually pretty easy to just assume, okay, everybody speaks English and everything is in US dollars, and just forget about all that stuff going on. But the user base for most mobile apps tends to be a lot more global than it is for most websites. Cool. That's also one of the things that you have to watch out when you're making PWAs, is you have to build up that expectation that, oh, I can handle other currencies and other languages, and so you tend to have to add all of those things to kind of get back up to where your users expect to be. Cool. Questions on that? Okay. So that's a little bit about formatting as it may be. I'm going to come back here and we will resume with the next part, which is reading input. And actually, I'm going to skip over this part for reading input because I think large in part it's
In this tutorial, I'm going to show you how to read input from the user.
needed.
In Java plus,
Yeah.
let me collapse this, that's better. All right, now it's time for a project.
Otherwise, you want to fix
So we need to multiply this number.
You said what? Oh,
Discord lost its screen.
yes. I thought I had it, but I guess I did not. So we may actually be here at the end. So I'm going to go ahead and skip over the reading part, talking about the scanner, because that's how to do input on the console, which we won't be doing, so it's not really relevant. It is relevant if you're working with files, but
Number by
that's not
12
what
or 12 months to calculate the number of payments.
And
Now, to raise this number to the, it's quite obvious to you that 12 is the number of months in a year.
let's see. They are doing stuff with mortgage calculator, which is input heavy. Let's see.
For executing code repetitively, casting, implicit and
There we go.
explicit. You learn how to work with numbers, strings, and arrays. And finally, you learned how to read input from the terminal. I hope you learned a lot and been enjoying the course so far. In the next section, we're going to look at conditional statements for controlling the flow of our programs. So I will see you in the next section. Hey, Mosh here. I just wanted to make a quick announcement. This course you've been watching is actually the beginning of my complete Java series. In this course, we only talk about the basics, but in my complete series, we go way beyond that. So if you're serious about Java, if you're looking for a job as a Java developer, I highly encourage you to enroll in my complete Java series. It's exactly the same structure, the same quality, but it has way more content. Plus, you will get a certificate of completion that you can add to your resume. So if you're interested, I put the link down below. You can get the course with a discount. And if you're not happy for any reasons, you can ask for a refund within the first 30 days. So I hope to see you in the course. In this section, we're going to look at control flow, or controlling the flow of execution of our programs. We're going to start off by talking about comparison operators for comparing values. Then we're going to talk about logical operators like the logical AND, logical OR, and logical NOT. We use these operators for implementing real-world rules. And then we're going to talk about 3 different types of control flow statements. We're going to talk about conditional statements for making decisions in our programs. Then we're going to talk about loops for executing code repeatedly. And finally, we're going to revisit our mortgage calculator and add error handling to it. So if the user enters an invalid value, we keep asking them to try again. All right, now let's jump in and get started. We're going to start this section by talking about comparison operators. We use these operators to compare primitive values. For example, are x and y equal or not? So I'm going to declare 2 integers, x and y. Now let's compare this to see if they're equal or not. So first, I'm going to add this print line statement. Now to compare these variables, we type x equals y. So here we have 2 equal signs, and this is the equality operator. Don't confuse this with the single equal sign that we use for assignment. That is the operator used over here, okay? So 2 equal signs represents the equality operator. Now when we run this program, we get true because these values are equal. This expression that we have here is called a Boolean expression. So earlier I told you that an expression is a piece of code that produces a value. This piece of code produces a Boolean value, true or false. That's why we refer to it as a Boolean expression. We also have the inequality operator. So when we run this program, we're going to see false. Let's take a look. We get false because these 2 variables are equal. So the expression x is not equal to y returns false. We also have greater than or equal to, less than, and less than or equal to. So if I change y to 2, this expression is going to evaluate to true because x is less than or equal to y. Take a look. There you go. Next, we're going to talk about logical operators. In the last tutorial, you learned that a Boolean expression produces a Boolean value. Now, there are times we want to combine multiple Boolean expressions. Let me show you. So I'm going to declare an integer called temperature and set it to 22. Next, we declare a Boolean variable is warm. Now we want to check to see if temperature is greater than 20 and less than 30. So we write a Boolean expression like this. Temperature greater than 20. Here we need to use the AND operator. So these 2 ampersands represent the logical AND operator in Java. After this, we add our second condition. Temperature less than 30. Now, if both these conditions are true, the result of this Boolean expression is going to be true. Otherwise, if at least one of these is false, the result will be false. Let's take a look. So I'm going to print is warm on the terminal. The result is true. But if we change the temperature to, let's say, 12, the result is going to be false. And this is how this works. Java will evaluate this expression from left to right. First, it looks at the first condition. The first condition is false because temperature is not greater than 20. So because this expression is false, it doesn't matter what we have after the AND operator. Java will ignore the other expressions because the AND operator will return true if both conditions are true. Okay? Now let's look at another operator. That is the OR operator. So I'm going to delete all this code and start with a new example. Let's declare a Boolean has high income. We set it to true. And another Boolean has good credit. We set this to true as well. So let's say we're building an application for processing loans. We want to see if a new applicant is eligible for a loan or not. So we declare another Boolean is eligible. And by the way, look at the names I have used for these variables. They're very meaningful and descriptive. So here's the rule. An applicant is eligible if they have high income or good credit. If one of these conditions is true, they are eligible. So we write has high income or, so these two vertical bars represent the or operator. So if they have high income or good credit, then they are eligible. So with the or operator, if at least one condition is true, the result will be true. In this example, when Java evaluates this expression, it starts from the left side. This Boolean variable is true, so it doesn't matter what we have after. Java will not evaluate the rest of this expression. It simply returns true. However, if this variable was false, Java would continue evaluating this expression, hoping that the next Boolean value or the next Boolean expression is true. So this is the or operator. And finally, we have the not operator that we use to reverse a value. Let me show you how that works. So let's declare another Boolean variable has criminal record. We set this to false. So here's the rule we want to implement. In order for someone to be eligible for a loan, they should either have high income or good credit, and they should not have any criminal records. So let's see how we can implement this rule. We have implemented the first part. They should either have high income or good credit. Now we want to make sure that they don't have any criminal records. So we need to combine the result of this expression with this Boolean value using the AND operator. So first we wrap this expression in parentheses. Then we apply the AND operator. And here we add has criminal record. Now we want to make sure they don't have criminal record. And this is where we use the not operator. So the not operator will reverse the value of this Boolean variable or expression. In this case, this variable is set to false. So when we apply the not operator to it, the result would be true. So if the first condition is true and the second condition is true, then that person is eligible for a new loan. So as you can see, these logical operators are very useful in implementing real-world rules. Next, we're going to talk about if statements. In this tutorial, we're going to look at if statements in Java. If statements are extremely important because they allow us to build programs that can make decisions based on certain conditions. Here's an example. In this file, we have a bunch of conditions. If temperature is greater than 30, perhaps we want to display two messages to the user. It's a hot day, drink plenty of water. Otherwise, if it's between 20 and 30, we want to print it's a nice day. And otherwise, we want to print it's a cold day. So let's see how we can implement these rules in a Java program. Back to our main file, we start by declaring a variable, temperature. We set it to 32. Now we use an if statement followed by a pair of parentheses. Inside this parenthesis, we type a Boolean expression or a Boolean value. So let's say temp is greater than 30. Now, if this condition is true, the statement that we add after this if statement will be executed. So let's print it's a hot day. Let's run the program. We get this message because temperature is greater than 30. Now, what if we want to print another message, like drink plenty of water? Here we should add curly braces to define a code block. So if this condition is true, all the code that we have inside of this block will be executed. Let's add another message here, drink water, okay? So this was our first condition. Now let's add the second condition. So after the right brace, we type else if. Once again, we add our parentheses, and inside this parentheses, we type a Boolean expression. If temp is greater than 20 and it's less than or equal to 30, you want to print a different message.
Really similar.
Like beautiful day. Now here I haven't added the braces because we have a single statement. So braces are only required if we have multiple statements. Now, this is a little bit controversial. Some people believe we should always add braces, whether we have a single statement or not. Other people, like myself, believe this creates unnecessary noise in the code. In this tutorial, I'm going to add the braces first and then remove them so you can see the difference. So let's add a pair of curly braces here. And finally, our last condition. So if none of these two conditions are true, then we want to print a different message. So here we simply type else. We don't have any more conditions. So let's add a code block and print cold day. Now, let me define a few terms. Here we have an if statement, and this statement has 3 clauses or 3 sections. Here's the first clause, here's the second clause, and here's the third clause. Pay attention to how I have formatted this if statement. So first we have the if clause. The else if and else clauses are placed after these right braces. So we have some kind of hierarchy here. Here we have a parent followed by 2 children. Now let's get rid of these unnecessary